All right, so I think I'm recording. We're looking at skill packet 5 that is exponential and logarithmic functions. And in skill 5G, we're solving exponential and logarithmic equations. Now, it also points out at the beginning of the skill packet for these first four problems that exponential functions and log functions are inverses of each other. So recall that with inverses of each other, if two functions are inverses, of each, well, let's use the inverse notation. If you do a function composition, that you get back what you started with, okay? Or if the composition is in the other direction, you get back what you started with. So here, if we're trying to simplify this, what I would probably do if I'm trying to understand how to get the answer is to come in and do a change of variable. I would let some variable, call it r, be this exponent. Okay, so I've got log base 5 of 6x minus 2. So I know that I can come back to this original expression, and I've just taken this exponent and said, hey, we're going to call that r. Well, what if I come over here and look at my equation that's in log form, and what if I change this to exponential form? The base is 5, a logarithm equals an exponent, and so this is equal to the argument 6x minus 2. So if I come back to my expression, I can see that I can replace 5 to the r, I can replace it with 6x minus 2, and that's my answer. Now, if you don't like this, if you don't like this substitution, what you can observe is the pattern that resulted from it. That I had a base of 5, I have a log base of 5, this 6x minus 2 is my answer. So you can try to understand that explanation. If you don't get too rattled. You can recognize the answer by recognizing patterns. Let's take a look at this second one. So again, if I'm trying to really understand why the answer is what it is, I would suggest doing a change of variables, a substitution. I would let r equal this 10 raised to the 5 minus x. And then I would come in and say, well, that's the same thing now of taking the log of r. But let's come in and rewrite this exponential form in logarithmic form. The base is 10, so that's a common logarithm. We typically do not write the base of 10 when we're in common logs. I'll put it in here just to help us for right now, though. The logarithm equals the exponent, and the exponent is 5 minus x. So like I say, this 10 for common logarithms is generally not written. Well, if I come back to the expression that I'm trying to simplify, I know now log of r is 5 minus x. And so that's my answer. Well, what if you didn't see that substitution? What if you don't know for certain how to illustrate that this answer is 5 minus x? You can recognize that there is a pattern that we've seen here. This base common logarithm has a base of 10. This base is 10. So the answer is they undo each other because they're inverses, and I have 5 minus x. Okay. So let's come in here, and again, if I do a substitution, if I let r be this exponent, this natural log of x squared minus 3x plus 2. So I can come to my expression and say, well, I'm just going to call this e to the r because I let r be this ugly mess there. Well, if I rewrite this equation that's in logarithmic form into exponential form, remember that natural log has a base of e. So I have this base of e. A logarithm equals an exponent, so e to the r is equal to this quadratic, this x squared minus 3x plus 2. I come back to my expression and say, hey, e to the r, I know what that's equal. That's x squared minus 3x plus 2. So I look and say, well, if I don't understand that explanation, then I can recognize just the pattern, and I can recognize that I have a base of e, the ln has a base of e, and then my answer is just this exponent, x squared minus 3x plus 2. All right, so what about here? If I say let r be this e to the 6th power, well, then I'm just taking the natural log of r. Let's rewrite this exponential as a logarithmic in logarithmic form. The base is e, so we typically will write log e for now, but really we'll use lm. A logarithm equals an exponent, so we've got the natural log of r is equal to 6, because normally we don't write log base e of r, we just write natural log of r, and that's equal to 6. Well, like I say, what pattern did we observe in these other problems? This base is e, this base is e, so we know that the answer is this exponent of 6. All right, so I hope that helps on those first 4 problems. Talk to you later.